Think math.
Here are four lists side by side. One shrinks steadily, one wobbles above and below 3, one swaps between 1 and -1, and one simply grows. Which of them converges? Wobbling looks like divergence, and being trapped in a range looks like convergence. But both guesses are wrong. There is only one test. The test is whether it closes in on a point. If the gap from some fixed number shrinks away without end, the list converges. If no such number exists, it diverges. Growing is divergence, and swapping back and forth is divergence too. Rising, falling, staying inside a range. None of those is the test. Start with the wobbling one. 3 plus -1 to the n over n runs 2, 3.5, 2.67, 3.25, straddling 3. Once below, once above. It never climbs like a staircase. Even so, the gap from 3 is 1 over n, and it keeps shrinking. So this list converges to 3. Moving in one direction is not required for convergence. Now, the opposite case. 1, -1, 1, -1 always sits between -1 and 1. It never escapes that range. And yet, it closes in on nothing, because whatever number you pick, the gap does not shrink. Pick 0 and the gap is always 1. Pick 1 and half the time the gap is 2. Staying inside a range and closing in on a point are entirely different things. What about the growing one? N squared runs 1, 4, 9, 16, 25, and passes every number in the end. 2 to the n does the same. Lists like these have no limit, so they diverge. They do not wander, though. They grow in one direction only, and we say they diverge to infinity. Infinity is not a value arrived at. It names the way the list grows. To sum up, convergence or divergence comes down to one thing. Does it close in on a point? A wobbling list converges if the wobble shrinks, and a trapped list diverges if it settles nowhere. Growing in one direction is called divergence to infinity, and there is still no limit. So watch the gap, not the rising and falling you see. Next time we sort divergence itself into its different kinds. A sip of math every day here at Think Math.